So we're going to go ahead and test the wire wrapping we just did for the address block decoding. And so let me show you what the setup is here. We've got the logic probe sitting down here, and I've got this jumper lead connected over to the input on the logic probe, and I'll use it to actually probe the signals on the board. The board's in the Altair bus. The machine's powered off. Let's go ahead and power it up. Machine's powered on now. I'm going to reset it. It's looking at address 0. And let's get up here on pin 8 here, if I can get connected. And let's look at what pin 8 is. So right now we're looking at the 7430 here, pin 8. And what it's saying is if A11 to A15 are all high, its output should go low. So right now I would expect the output to be high, and it is. So let's set A15 to A11 high, and let's do an examine. And when we do an examine, we should see that toggle to a low. The red LED should go out on the logic probe, and the green should come on. And that works. So that's very nice. Now I'm going to take each of the addresses A11 through 15. I'm going to take each one low individually and do an examine. And we should see the high LED indicator come back on. And it did. And we'll test A12, A13, A14, A15 being low, and now I've got them all high again, and we see it go low. So that's excellent. That says that 7430 is doing its job, and when we're looking at the upper 2K of RAM, that pin's going low saying, hey, you're in that upper 2K of RAM. The next thing to look at here is the 3 to 8 decoder. And what it does is look at address A8, A9, and A10 and decodes those from a 3 to 8 and takes, as we've talked about before, one of these 8 outputs here to low to say, hey, I want to talk to ROM 0, ROM 1, ROM 2, ROM 3, etc. So we're looking at address F800. So I would expect that to be looking at ROM 0, just as we've written in down here, F800. So let's look at that output over here. And that output is pin 1 up under here, and it's really hard to get at. And we see that it's a low. If we look at ROM 1, we should see a high. ROM 2, ROM 3, ROM 4, ROM 5, ROM 6, ROM 7, and up here is ROM 8. So that's excellent. So it's only saying, hey, I want to see ROM 0. So now let's go to address what is it, F8 or F9, which would be ROM 1. And when I examine here, we should see this signal go high, and we did. And the next one should now be low, and it is saying, hey, I want to look at the next ROM, and this should be high over here now. So let's go on and look at ROM 2. Well, the third ROM, let's look at the third ROM, and we see it go low. Now let's look for the fourth ROM. And that would be here. And we see it go low. Fifth ROM would be, I have to think about this right. These switches here. The next ROM will be right here. And we see it go low. The next ROM will be right here. And when I examine, it should go low. And the final ROM, it's enables out up here on this pin up here. And when I examine, we should see that go low. So that right there says to me that the address decoding is working, which is excellent. And this is acting like it was designed to act. With this ROM enabled up here, if we change one of the addresses from A11 to A15 that moves us out of that upper 2K block, we'll just change one and examine. We should see this go high. And all of these should be high along here. And they are, and that's exactly the behavior we'd expect. So let's take this a step further. I've got all the cards, like I said, in the MSI at this point. Let's turn on the floppies. Let's make it a little loud. I've got the floppy mounted in the drive. Let's set the address to FF00. And when we do an examine, here we should see this guy come low. How didn't I see that come low? Actually, no, we should see this guy right here come low. So the boot ROM for the machine is that last ROM from address FF00 to FFFF. Now, there's no ROM on the board we built. The ROM is actually on a different board in the machine at the moment. We're just looking at the address decoding here. And what we should see happen here, when I go ahead and boot CPM, is we should hear the floppy access, and there should be a lot of activity at that point on this pin. So let's see if I'm correct. So I'm going to go ahead. We've examined. I'm going to go ahead and run. And hopefully you saw that and heard it. So the Logic Pro makes a little buzzing noise when there's a state transition, and I heard the floppy access. Let me go ahead and stop the machine. We'll go back and examine address FF00. We should see the Logic Pro bootable low. And when I run here, again, we'll see a bunch of activity as the ROM at that address space is being accessed. Even though it's on a different board, this board here would be decoding as if it was on this board. We should see a bunch of activity, then once CPM's booted, this should go back high. And that's exactly what we expected. So this says to me my address decoding is working as expected. At this point, this card isn't messing up the S100 bus and keeping the machine from booting. The board's really completely passive at this point. It's looking at A8, A15, and not really anything else. So it's not putting data onto the bus or anything, so I wouldn't expect it to affect the machine unless like I had a short between a couple of pins or something. But anyhow, I think that's a successful test. Happy we've gotten this far, and I guess we'll see you in the next video.